In this section, we'll take a look at applications of the law of cosines. Example, suppose a boat leaves a port and travels 10 miles. Then it turns 20 degrees and travels another 8 miles. How far from port is the boat? So there's an image on this one, and we can see that leaving the port, that the ship goes that 10 miles and then makes a 20-degree turn. So leaves the port, goes 10 miles, makes a 20-degree turn. So that 20 degrees is the little piece up at the top, and then goes another 8 miles. And the question is, how far from port is the boat? How far from port is the boat? So that is this diagonal that I'm going to identify as x. And I will say more formally, let's let x equal the distance that the boat is from port. And the unit on that is miles. So we have been given a side. We have been given not a direct angle, but I think we've been given part of the angle, right? So if we take a look at this before the turn, that is a straight line, or we might think of it as half of a circle. So if 20 degrees has been given to us, then that interior piece would be whatever 180 degrees minus 20 degrees is, or 160 degrees. So we were given the side of 10 miles. We now know the angle of 160 degrees, and we also know the side of 8 miles. So we have a situation where we have a side angle side triangle, and so we're going to use the law of cosines to solve. We want to find x, so I'm going to say that x to the second power is equal to, I'm going to look at the other two sides, 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of the angle that is across from that side of x, which we calculated as 160 degrees. All right, so I'm going to put all of that into my calculator, and I get x squared is equal to 314.35. And when I square root and I round, it doesn't tell me how much to round, but let's round to the nearest tenth. That gets me approximately 17.7 miles. So I can say that the boat is 17.7 miles from port. Let's try another example. Two planes leave the same airport at the same time. One flies at 20 degrees east of north at 500 miles per hour. The second flies at 30 degrees east of south at 600 miles per hour. How far apart are the planes after 2 hours? Now, one part that I skipped over reading was when I said that one flies at 20 degrees east of north. As a bearing, we would write that as north, 20 degrees east. In navigation, we'll look down here at the bottom, in navigation and surveying, directions are usually given by using bearings. What is a bearing? A bearing is the measure of an acute angle, so less than 90 degrees, from due north or due south. That's why this one started with north. The second plane flew at 30 degrees east of south. As a bearing, we wrote either the north or the south. In this case, it's the south. We wrote that first, and then 30 degrees east. All right, so let me show you what that might look like. I always like to draw an XY axis. I find that the XY axis is set up perfectly for these bearing problems because the positive y-axis is us heading north, the negative y-axis is us heading south. To the left, the negative x-axis would be west, and the positive x-axis would be east. Okay, so we're going to have these two planes starting at the origin, let's say, and the first plane is going to head north, and then go 20 degrees east. So we head north, but then we're going to move to the right. So you'll see me head north and then go 20 degrees east. So 20 degrees east. And then the second one is starting also from the origin, but this time we're going to head south, go directly south, and then go 30 degrees east. So a little bit steeper, 30 degrees east. And these are not drawn to scale. We're just trying to get a feel for it. And the question is, how far apart are the planes after 2 hours? After 2 hours. Okay, so we have the angle measures. The other piece that we have is we know the speed of the planes, right? So the first one was going at 500 miles per hour. So after 2 hours, this distance is 1,000. And the second one, going 30 degrees east of south, was going at 600 miles per hour. So the distance that this one has traveled is 1,200 miles after 2 hours. I'm going to let that third side be x, and x is going to represent the distance between the two planes after 2 hours. After 2 hours. Okay, so let's see. What type of triangle do we have here? We know a side. We know another side. This one's a little bit like the last one we saw in that we were given some angles, but not the direct angle that we need. What we need is the measure of this angle that's on the inside of the triangle. And again, if you take a look at a straight line, that's half of a circle, isn't it? So half of a circle is 180 degrees. So this inside angle, let me just highlight it a little bit. That inside angle right there is going to equal whatever 180 degrees minus 20 degrees minus 30 degrees is. And I think that that gives me a 130 degree angle. Okay, so what has been given to me is a side of 1,000, an angle of 130 degrees, and then another side of 1,200. So we're going to use the law of cosines to solve for x. So I'm going to say that x to the second power is equal to, we've got our other two sides, 1,000 plus 1,200 minus 2 times 1,000 times 1,200 times the cosine of 130 degrees. Those are going to be some big numbers. So I'm glad I have a calculator. When I put all that into my calculator, I got, let's see, 3,982,690.263. Let's put some commas in there. So what is that, like 3 million, almost 4 million? When I square root each side, I got approximately 1995.667874. It might even keep going. Let's see here. They don't tell me how much rounding to do. So let me just go ahead and round to the nearest whole number. That seems to make sense. So I would say that after 2 hours, the planes are approximately 1,996 miles apart. So really, the computation is not bad. It's setting up the picture, and then in this case, a new thing for us to know about, which are the bearings. Bearings always start out north-south, and then they either go to the east or they go to the west.